Hello, today we're going to look at three-dimensional area and volume, and we are going to look at the tolerance or accuracy of measurements involved in these shapes. Now, if I have this shape here, which in exams might be called a buoy, as in an object that floats out in the ocean to mark sea lanes, find the total surface area of our shape here. So the first thing I have to do is look to page 10 in my log tables and look for shapes that I can break up this more complicated shape into. So I have no formulas for something that looks like this at all. But I do have formulas for things that are parts of this shape. And this is the first key skill, taking these complex shapes and breaking them down into pieces that we have formulas for. And the formulas we need are on page 10 in the log tables. So let's have a look at them. The top of my shape here, I recognize, is a right cone. So if I want to find the total surface area of that, the total surface area, so the area of my cone part, which I'm drawing roughly as a triangle, is going to be pi or L. Pi or L. And from page 10 in the log tables, I can see where I have my cone, that L is what's called the slant height, or is the radius of the base, and pi is just a number. So I have my pieces of information I need for the area of the cone top of the shape. Well, what's the bottom of this shape? Well, it's a hemisphere. It's half of a sphere. So what is the area of a sphere? So the area of my sphere would be 4 pi r squared, and I'm dealing with a hemisphere, which is half of that, so it's a half of 4 pi r squared. I have my sphere, and the radius is r. I have a sphere, so I can draw a little shine on my bubble. So I'm dealing with my shapes here. So I now know what I need in order to get what I want. So what information have I got? What information do I need to find? Well, I can see only two variables here. The radius of the bottom of the cone and the radius of the sphere are going to be the same. So that or means the same thing in both formulas. So I just need to know what the radius is, and I need to know what the slant height is, what this side of my cone shape is going to be. So to get that, the easiest one is to look at the radius, because I'm effectively given the diameter of this hemisphere and the diameter of the base of the cone, because I'm told that all the way across the maximum width here is 1.8 meters. So the radius I am able to figure out, and I know I'm looking for it because I know what formulas I'm dealing with. The radius is going to be 1.8 all over 2 is 0.9 meters. Now, how am I going to find the slant height? Well, to do that, I recognize that I have a right cone. Now, a right cone is basically the only type of cone we have to deal with. So if we have a cone shape, it is, if we looked at its side on, we look at our cone side on, it effectively becomes like a right triangle. So we'd have the cone kind of coming out at us from the page here, and it has a particular height, and it has a radius from its base, and it has a slant height. So I know the radius now is 0.9. How would I be able to find the height and the slant height? Well, I can see that from the very bottom of the shape up to the very tip of the top of the shape is 2.1 meters. And I know I have my hemisphere coming down here. So I have gone down, if this is a hemisphere, I would go down 0.9 meters plus h must add up to 2.1 meters. So let's write this the other way around. 0.9, the radius, plus my height must be 2.1 meters. So my height must be 1.2 meters. Now I recognize, again, a right cone. So I have a right angle triangle here. I now know h is 1.2. H is 1.2. The radius is 0.9. What is my slant height going to be? Well, it's going to be L squared is equal to h squared plus r squared, Pythagoras. And again, you can see by breaking up, by finding out what shapes I'm dealing with, and then looking for what information I'm able to get, I can work my way through all of these steps and be guided, guiding myself as I go through. So L squared is equal to 1.2 to be squared plus 0.9 to be squared is 9/4. Take the square root of both sides. This is a length, so I don't need to worry about the plus or minus. So L is equal to 3/2 is equal to 1.5 meters. You can leave it as a fraction or as a decimal. You will get full marks for either unless they specifically ask you to give it in a particular form. It's meters. So we now know the slant height, so we know the R and we know the L. So now we're able to sub in and find this stuff. So the total area, we do this out separately. For a complicated shape, it might be no harm to do this out separately. So let's do the area of the cone part is going to be pi on, I have my formula here, or is 0.9 on L, I have just found is 1.5. And when I put that into my calculator, I get 27 all over 20 pi. Now you can write that as a decimal if you like, unless they ask you for your answer in terms of pi, in which case leave pi alone. It's often better to leave it in this form because decimals lose accuracy, you lose information, sometimes things cancel out nicely. So it's a good idea to leave it in this kind of form rather than forcing it to go to decimal. Sometimes you will have to go to decimal, but if we can avoid it, we should. 4 pi on 0.9 squared. So I have my area of my hemisphere, half a sphere I should say, is going to be half of the area of a sphere, and my R is still 0.9. When I put that into my calculator, I get 81/50 pi. And then my total area is going to be 27 pi all over 20 plus 81 pi all over 50 is equal to 297 pi all over 100 meters squared. And don't forget your units, we're dealing with area, so it's meters squared. Let's try that again. So that's how we approach all of these types of questions. We're going to break up our complex shapes into things that we have formulas for. How do we know what formulas we've got? Well, they're in page 10 of our log tables. We see what we can break things up into, and then we can work through the formulas that we're given in our log tables. For the most part, will get us through what we need to find. But if we follow the steps of what shapes have I got here that I know formulas for, write down those formulas and see what information I can get, and then what information I need to go looking for, that will guide me as to what I need to do. And if I can keep my head and do that, I will be able to get through these questions. and that's what we need for basic area and volume.